So I'm almost, oops, wrong thing. I'm almost having like an obsessive compulsive can't give up control moment. But I want to, because I want to go over your notes with you if I can find the right document to open. Um, you can see what time it is, 9 o'clock at night. Maybe that's why I can't see it because I'm tired. Note sheet key, there we go. I want to go over the answers to the notes with you. That way, I can kind of highlight a few things that I want you to remember. So as I go through and highlight these things, you might want to make marks and different things. So change these as you need. The first person who hypothesized continental drift, was Alfred Wegener. He's actually German, and so if you know anything about German, the W sounds like a V, which is why my maiden name was what it was. It was Drever and not Drewer. Okay, so it's Wegener, just so you know. Name the former supercontinent made up of all current continents. That was called Pangaea. Some people say it's Pangaea. I prefer Pangaea just because I do. Continents moving farther apart from each other. That's known as continental drift. Evidence for continental drift. I have identical rocks / mountains could be found on either side of the Atlantic Ocean. Oh, by the way, you might want to star continental drift. That's something you'll definitely need to know. Next blank, the same plant and animal species were located on different continents, even though there was no way for them to travel such a long distance. Coral reef fossils exist in locations too cold for them to grow. And then the reason that scientists did not accept Wagner's theory is that there's no mechanism. And what we mean when they say there's no mechanism, like there's no reason why. He couldn't explain why these things were happening. He could just say they did. So he didn't really have an explanation or any proof for it, which you can see why that would be so hard to believe. Like, hey, these giant continents move around the earth. I don't know how, but they do. You're like, good idea, not. Okay. So there's no mechanism for it. There's materials called magnetite. Magnetite is like a magnetic rock is really all it is. And those little pieces of magnetic rock always pointed north, but they didn't always lay the same direction, so it shows that continents had to slowly move. If I was there and I would have had time, I would have made these fancy like continent cutouts, and we would have done like some acting out of this, but it's not that important for you to know. Just know that's some evidence. You can just memorize it even if you don't understand it. I'm okay with you doing that on. Your reading called this echo sound producers, which is a device used to study the ocean floor. So really, echo sound producers are radar. That's why I highlighted radar in red so that it stuck out to you, that I had added that on your sheet where it says AKA radar already there for you. No, that's what echo sound producers are. So the things they found on the floor using radar, they found mountain chains, or in other words, mid-ocean ridges. You're going to want to highlight where it says mid-ocean ridges, or underline or change it, bold it, something, because I'm going to refer to like the mid-oceanic ridge quite a bit when you do any homework or on your tests, for example. Okay, so they found ridges, deep sea trenches, and something called abyssal plains. If you just have the word plains written down, that's fine. In fact, I'm just going to erase abyssal because I don't even know what it is. Big flat areas, right? Okay, appeared as stripes due to the changing magnetic poles. So magnetic basalt beds, so areas of rock, they'd almost have stripes in it because the magnetic poles are changed direction. So where the south magnetic pole is now used to be the north magnetic pole, and then it was the south magnetic pole for a while, and it keeps switching. The way I usually think about this is I think about when you mow the grass. Okay, when you mow the grass, it's still cut grass, but the strips are slightly different colors. Okay, just because of the direction that you mowed. So it's the same thing, it just looks slightly different. That's kind of what those stripes on those basalts look like. It's very subtle, but you can see it if you have the right equipment. Okay, so think about those stripes, the stripes in the grass. Okay. Seafloor spreading is the idea that says hot magma comes up at the mid-ocean ridge and pushes the crust away from it, causing the ocean floor to get wider. Convection, you're going to want to put a star next to that because it's in your other notes as well. So convection is what's occurring in the mantle to allow seafloor spreading, and this is what is actually the movement of continents. So this was the mechanism that Alfred Wegener was searching for, was convection. He just didn't have any proof that this was happening. So they found these the mid-ocean Atlantic ridge in the Rift Valley underneath the Atlantic Ocean and realized that convection what was causing this. Convection is what powers all of this. And that question that you had yesterday about what does this have to do with anything? It's right here. This is what's going to cause the continents to move and also some plates to move, which ultimately causes everything. As far as volcanoes and earthquakes. So Earth's tectonic plates, what they are, they're large areas of lithosphere that can remove. Remember, yesterday we talked about lithosphere, that's the bottom part of the crust in the very, very upper part of the mantle. Okay, plate tectonics are the movements of plates over Earth's surfaces. The plates move at the same rates as your fingernails grow, so you can't really, you would never be able to see that difference in a lifetime. How long your fingernails grow. That's like maybe 3 feet. You'd never notice that happening across that amount of time. Okay, so divergent plate I scrolled down too far. Tectonic plate boundaries, there's 3 main kinds. What a plate boundary is, it's where 2 plates meet. The 3 main kinds are divergent, convergent, transform. So divergent, remember you learned this in middle school, if you dive away, they dive away from each other. Convergence, they come together, and I'm clapping because that's how you usually taught it, right? Dive, I move my hands away, converge, they come together. Transform is when, and maybe you can hear it in my mic, it's like when you're rubbing your hands together to keep them warm. Okay, they're moving in opposite horizontal directions of each other and rubbing against one another. All right, so when divergent plate boundaries form rift valleys, you're going to want to star rift valley. That's another important word that you need to know. These are formed when plates are moving away from each other. So the rifts are basically holes with no bottoms. So a rift valley is a place where there's no bottom. Actually, I want you to add that to your notes. So this is something new. You need to type this or write this, depending upon how you took your notes, and you say a hole with no bottom. Okay, that's important, very important for you to know. Africa is the continent that has a divergent plate boundary on the land, and you can see that in those pictures that it showed you in your reading. Atlantic Ocean is the ocean. A divergent plate boundary is located underneath. That's where they found the mid-ocean Atlantic Ridge and also the mid-Atlantic Rift Valley. Convergent plate boundary is the kind of crust that's more dense when these are oceanic crust just in general. And so when there's a subduction, a sinking of a plate into the mantle, that's going to be important. Okay, so subduction, sink of a plate into the mantle. Subduction zone is the area along a convergent plate boundary where plates sink. Okay, so you have one plate that's sinking and one that's going over the top. Okay, it's like if you took your fingers and slid them together. You know what? I'm actually just... Okay, keep in mind it's late at night. Okay, so, and there's not a great light on this. Okay, so if you do this with your fingers, a subduction zone is like this. Okay, you have your continental, your less dense plate is up here, and then your more dense plate, your oceanic crust is sinking down below. Okay, so oceanic continental, those are the kinds of plates that are hitting each other to subduction zone. The more dense plate sinks into the mantle. The most common location for these to be found is the Ring of Fire, and because those are the most common place for subduction zones to be found, that's where a lot of volcanoes and earthquakes are going to take place. Okay. When you create mountains, this is when you have continental and continental crust meeting each other. Continental crust is all the same age and all the same density, so when they hit, it's like this. Okay, if you take your fingers and you push them together really hard, you'll kind of see like, oh, this knuckle buckled up. These guys are kind of trying to come up. Don't hurt your fingers doing this, right? Okay, but they go up like this, okay, and make mountains. All right, the mountains, the most famous mountains that are made this way are the Himalayan mountains. Those are the tallest mountains. If you were to look on a map, this is actually where the continent of India, which is on a plate, is running into Asia north of it, and they run into each other, basically right on the border of India, and make those giant mountains. Transform plate boundary, the most famous one is the San Andreas Fault. That's actually located in California, and the other main one is located in Turkey. Both of these are near very populated areas, which is why they are very important kinds of plate boundaries to know about, even though they are very rare. Okay. And then there's also something that's not really, it's not technically a plate boundary, so I didn't put plate boundary behind it like some of the other, like you guys probably did. But in plate location where we talk about intra-plate activity, intra means inside, so we're talking about inside a plate. So places where earthquakes or volcanoes even occur where there is zero plate boundary. There's nothing there, but there's still activity. We'll talk about that when we actually talk about volcanoes and whatnot later on. So that is your note check. Hopefully you guys got this change written down next to Rift Valley, that addition, I should say. So go ahead and make sure you get that added. Make sure you starred those couple that I told you to. And other than that, that's all I have. Then tomorrow you're going to watch a video that'll kind of review a lot of these topics. So it'll be about 20-30 minutes long. And then you're going to make a model. So you're going to do some drawing and some labeling of different things again. But this time you have to have moving parts. Okay, and I will tell you ahead of time, moving parts can be pieces of paper, okay, that you cut out and you can move around. So keep that in mind for tomorrow.